So 3-3 homework. Then they give you like 6 problems or something, right? Last Friday?
Okay, so this is the one with like thing that you gave us cues to do, yesterday to do.
Oh.
And then I actually did.
Okay. And then there, that's.
So I'm telling you that I did all.
So, let's see here. I know what I need to do. Homework is evil in terms of being able to keep track of it all. So, okay, I got you there now, Fiona. That was like that was the previous lesson, I think, right?
It was like, you gave it to us on like Wednesday and then
Yeah.
Thursday.
Yeah, and then we took 2 days, that's fine. Jackson, I never saw a lesson on page 136, the second lesson. I didn't see that from you. You said you didn't have it or something, I don't know if you've done it or not. That doesn't look like it's all done. I gave you 1 and then 14 through, what was it, like 18 or 16? 19. Because,
Did you mean 136? That's what I have.
yeah, is that what I said?
I got
Okay.
it.
You have that, you think? Is it because you had difficulty with it, or you had difficulty disciplining yourself to do it? Doing it?
Yeah.
It was what it is. You didn't do it. Let's go over 15. Raven, you got through it. All right, so let's see here. Keeping track of homework is a great evil. Okay, so number 15 says, is that the Jordan collects baseball cards? Yeah, so he collects baseball cards, and last Saturday he had 200. And he then bought 1 pack of cards on each weekday. Oh golly, yeah. Maybe we should write it out. How many does he have on Saturday? 200. And then, got Monday, Tuesday, Wednesday, Thursday, Friday. Let's just kind of take a look at how this looks. And then he buys how many on weekdays? A pack. And 2 packs on Saturdays. Wait a second, hold on. Last Sunday he had 200 cards. All right. So how many does he buy on Saturday?
2. In total, he gets 7 packs in a week.
Well, he's got 2 cards, two packs. And then how many on Sunday?
None.
Oh, you don't need that. We don't need this. What am I doing? Tell me to stop. I'm not doing this right. Here we go. Sunday. Monday he buys how many packs? 2?
1.
1. And then he buys 1 all the way, right?
Mm,
And then on Saturday he buys 2. So we're asking how many he has here, is that right? Does it tell us how many cards are in a pack?
No, that's what you're trying to figure out.
That's what we're trying to figure out. But he has 284, right? So if he's adding a pack, how many packs does he add to his 200?
7.
7, thank you. So then it's 200 cards plus 7 packs is equal to 284. So maybe writing this is the hardest part. And then P is going to be the number of cards in a pack. How many cards are in a pack?
I got 12.
You got 12. What did you get, Raven?
12.
You got 12? Because if you took 200 away from each side, 7 packs would be 84 cards, and then if you did the division, that would be 12. That would work. Okay. Any others? Any other questions from this? Please ask. I won't answer if you don't ask. No? Okay. Guess what? We move forward, solving. So we're going to go back to basically what I showed you for getting the previous lesson done. And the only thing is that when we're solving equations of this form, the coefficient can look different, and I want you to become comfortable with that. So 3-4, solving ax plus b is equal to c. So this is solving equations of a form where you have, this is a coefficient here, a. And then x is the variable, and b is called a constant because it's a number that remains the same that we add whenever we look at this equation. So from that, we need to use inverse operations, no change. But the examples, they show different kinds of coefficients. So the first one, the coefficient is a -3/2. So they say -3/2 x minus 53 is equal to 7. So here the constant is going to be a -53 because the value that's being added would be a -53 if we rewrote this as the addition of a negative. So we have to go backwards through the order of operations, and the first thing we have to do is undo what? Multiplication or this subtraction? What has to be undone? Subtracting 53 or multiplying by -3x? Subtracting. So what's the opposite of subtracting? You can think of addition. That has to happen on both sides and then simplify. So what would the next line look like? How would I write the next line across here? Talk louder, you're talking through a mask. How would I rewrite it?
-3/2x equals 60.
Okay. And then we have multiplication by -3/2. So how are we going to undo multiplying by -3/2? You say divide, but remember we can't divide fractions, instead of dividing fractions, we have to multiply by the reciprocal. So what is the reciprocal of negative 3/2? Is this correct? Negative 2/3. Because that way a negative times a negative will be a positive. Otherwise we'd end up with a negative x, which we'd have to change. So then if we multiply the left by that, the right has to be multiplied by that also. These two will become 1 times x. Can you simplify this before you multiply? Can you? Two-thirds can't be simplified, right? But because it's multiplication, 60 over 3, can that be simplified? What would it turn into? 20 over 1. Just do that in your head if you wish. What's 20 times negative 2? Negative 40. And then go back up here, see if you can pull that off. Gosh. If you did, if you were going to check this, you'd have a negative 3/2 times negative 40 minus 53. So the 40 and the 2 can be simplified. And that's 20 and 1. So 3 times 2 is 6, times 10 is 60. This is 60 minus 53, that's 7. So when you check it, you don't have to go work it all the way out. Just write down enough that you can do mental math in your head. Do not change these two decimal numbers, please. Leave them as fractions. Do all of your work as fractions. And the reason is, if you end up with, you're starting with fractions that are things like thirds and sixths and sevenths, there is not a decimal equivalent to those that you can easily enter into the calculator, so you're just going to be counterproductive if you do so. Right. So, example 2. Val and the zoo. When Val works at the zoo on Saturday, she earns $10.80 an hour. She is also paid $8 for meals and $3 for transportation. So she gets like a per diem spending money per day. Last Saturday, she received $83.90. How many hours did she work? So we need to write an equation for that and solve it. So you're going to find in this lesson, there are going to be some problems where they just give you an equation that you just kind of do the inverse operations, you do the grunt work to get through. Others, you have to start with an equation that you write to solve. So she has her hourly added to her meals, and is it transportation? So those are all equal to the total that she earns. Which, maybe we could actually write that as a W, because that could be wages. This is her wage. So how do we write how much she makes per hour? What does she get paid in 1 hour? 10.80. So then if she worked 4 hours, how would you figure out how much her hourly was? Times 4. So in this case, we might say that it's 1080 times the number of hours h, because that's what the variable is that we're trying to find. How many hours does she work? And how much does she get paid for meals? Each day, how much?
$8.
8. And how much for transportation?
3.
3. So that makes a total of, she gets $11. And then it goes and it says that her wages on a particular day were $83.90. So working backwards, we can take away her meals and transportation, her per diem, take that away from $83.90, and then use this fact to figure out how many hours she worked. So inverse, take away 11. And just divide by 1080. So what's 72.9 divided by 10.8? That's calculator. You have the calculators, go. More than 10 or less than 10? Less than 10 or more than 10?
No.
So what does this come out to? What you get, Marvis? You guys each have calculators, why can't you be doing this to help you move things along? They won't give you these things so you can just walk around and look cool with them. Do you guys not have yours today?
It's at home.
7290 divided by 1080. 6.75. Or 6 and what fraction? How much? 3/4. So she worked 6 hours and how many minutes? 6 hours and 45 minutes. You got paid that. Okay. So the third example and the last one, I think. Yes, the area of the largest rectangle is 94 square centimeters. What's the value of n? So this goes back to some of these area equals length times width drives. I notice you guys aren't writing anything into your notes. Which means then you don't have it to help you with the quizzes. Okay. So the whole thing is equal to 94. Area is 94. They give units, they say centimeters. Centimeters squared. So this must be 4 centimeters, 3 centimeters, and then n plus 10 is centimeters. We need to find n. So how do you write a formula, or I'm sorry, how do you write an equation for solving this? So give us the area. Is there a formula for rectangles that includes area? Length times width. Okay, so you don't have to necessarily write this, but certainly think it's length multiplied by width. So now the area is 94. And if you look at your drawing, what are the length and the width? Ooh, hold on, the area of what? The area of the largest rectangle is 94. Okay, good. I was thinking the shaded, but that's not true. So how do we write length times width using this information? They're saying the largest rectangle, so the whole thing is equal to 94.
4 times 3 plus n plus
Okay, is that an okay way to write it? This is an important step. Is that okay? What's the shaded area? How much is it?
12.
It's 12. So this right here is 12, and then we don't just add n plus 10. The whole side along here that all needs to be multiplied by 4. Because this portion right here is going to be 4 multiplied by n plus 10. And this area here is going to be 4 multiplied by 3. So we show you these rectangles to help you set up the distributive property in the equation. So in here we have to take 4 times the 3 and 4 times the n plus 10. So we have to distribute like this.
12 plus 4.
12 plus, and then it's 4 times the n plus 4 times the 10. 4n plus the 40. See, this one is tough. But if you look on the inside, everything is addition. So what we could do is we could say that this is 4 multiplied by n plus 13. That's another way of looking at it. It might be easier. And then when we distribute, that becomes 4n plus 52. And if you look here, there's the 52, and there's the 4n. So 4n plus 52. So whichever way you want to get that. I think it's easier when you have parentheses nested like this, inside of parentheses, and everything is addition, that you just combine like terms and then distribute. So once you get to that point, you have 94 is equal to 4n plus 52, and we can get ourselves to solve for n. So, once we get to this point, which step should we take?
Subtract 50.
Yep, thank you. Subtracting 52. So then 4n is 42. Divide by 4. You can do that in your head if you wanted. Here, I'm going to come up this way. So now you have 42 over 4, which is 21 over 2. What's 10.5? Or 10 and a half, either way. But it's centimeters, I guess, so 10.5 would probably be a nicer way of writing it. So 10.5 is what is going to be equal to n. So then if you go back to check, and then this is 3 plus this, and that has to be multiplied by 4. So this ends up being 23 and a half times 4. And if you put 23 and a half times 4 in your calculator, I think you'll see it comes out to 94. So a couple of things I'm going to write over here on this board in black. The variations of this ax plus b is equal to c. Sorry, I'm going to make you have to look around. You could see it written like so. We have a number is equal to 3 over 2x minus 53. You could have it written like this, negative 53, negative 53 plus 3 halves x is equal to 7. That's the same thing. All we did is we changed the order of the 3 halves x and the negative 53. You could also go and have everything on the right-hand side of the equal sign written on the left. You could switch sides here. So it could be like 3 over 2x minus 53 is equal to 7. And it still means the same thing. We're just changing the position of each of the terms. And the last one here is that we could take this and put the 7 equals everything on the right-hand side. So that'd be negative 53 plus 3 halves x. So those all mean the same thing. And if you like putting the terms in different positions so it's easier to look at, that's fine. And I've seen some of you do that. I've seen some of you take some of these and say, well, you know, I don't want the x here, I want it on the other side of the equal sign. But, you know, I want it out here, I want subtraction instead of this. You can rearrange as long as you keep the positives and the negatives straight with each of those. Good. You think of this is a negative right here, so it's going to be like plus a negative 53, and that's where that comes from. Here, this is a positive 3 halves, so we have to add it if we write it after the negative 53. Just keep that kind of stuff in mind when you do your work. And you're welcome to rearrange formulas and equations any way you wish, as long as you follow those rules. So, homework.